Hello everyone, my name is Vijeesh from Electrical and Electronics Department. Today we are going to discuss the linear voltage differential transducer. The short form is LVDT. The LVDT is used to find out the displacement of a moving object. This is a locally available LVDT. Let us start with the connection diagram of an LVDT. Simply LVDT is in the form of a cylinder. Inside of that cylinder there is a core made up of a magnetic material, and there will be a primary coil, and it will be connected to the AC supply. There will be two secondary winding. One is here like this, another one is here like this. Both these secondary winding will be connected in phase opposition, because the output voltage produced here V0 should be the phasor difference of V1 and V2. That is, because the number of turns of both the secondary winding is same, the voltage V1 and the voltage V2 should be same. That's why V0 equal to V1 minus V2, because it is connected in phase opposition. That means the current flow through the first secondary winding moving downwards, and that current will moving to the second secondary winding in upward direction like this. That's why the whole voltage produced by both these winding will be in phase opposition. Now we can go for the working principle of this LVDT. Before that, first we need to consider the first position. That is, if the core is in the exact center position of the LVDT, then the primary winding is provided with a voltage of value Vs. Due to electromagnetic induction, the secondary winding will produce a voltage of V1, and another secondary winding also produce a voltage of V2. If the core is in the exact center position of both the secondary winding, the flux linkage from the primary winding will be same in both secondary windings. That's why in this situation V1 equal to V2. That's why the resultant voltage V0 equal to V1 minus V2. That's why the LVDT produce a voltage of 0 if the core is at the center position. If the second condition is, if the core is in the downward, the major part of the core is in down position, then the flux linkage of the second secondary winding is greater than that of the first secondary winding. That is, here V2 is greater than V1. If the major part of the core is in first secondary winding here, then the flux linkage of the first secondary winding will be higher than that of the secondary winding. That's why the voltage output of the first secondary winding V1 will be greater than V2. This is a basic working principle behind the working of a LVDT. By using the position of the core and the output voltage, we can find out the movement of that core. In order to find out the displacement of a moving object, that object should be connected to the LVDT. By moving the object, thereby moving the core, we can find out the value of displacement from the output voltage of the LVDT. Now we can go for the simple signal conditioning circuit of LVDT. The output voltage of the LVDT should be conditioned and amplified for processing, because the value of LVDT produced is very less value. That's why we need to amplify that value. That's why we can get the amplified output voltage, output DC voltage here. Now we can go for the output voltage graph with respect to the core displacement. Here this is a primary winding, this is a first secondary winding, this is the second secondary winding, and it is connected in phasor opposition. If the core is at the center position, that is here, if the core is at the center position, that is here, then flux linkage of both secondary winding here and here will be same. That's why the voltage V1 and V2 will be same. That's why the output voltage V0 equal to V1 minus V2, that is equal to V minus V, that is 0. That's why that point is in the 0 position. If the core move more downward position, that is the core here, then flux linkage will be higher in V2, that is flux linkage is more in secondary winding. That's why the value of V1 equal to 0. That's why we can find out V0 equal to 0 minus V2. Hence the point is here. Now if the core is near the first secondary winding, then the flux linkage in the first secondary winding is more than that of the second secondary winding, that is V1 equal to V and V2 equal to 0. That's why V0 equal to V minus 0. That's why we can get a point here. The first point here, during that situation core is at the center position, here core is at the top position, here core is at the bottom position. By using this graph we can find out the displacement of the core. Thereby we can find the displacement of any object connected to the LVDT. Thank you.